All right, I'm going to pick on someone at random, and that person's going to be Austin Cool. Austin, let's go for critical points here. Okay, guys, let's slow down here, please. Now, Austin Cool, what's the derivative of sine x, please? Good. What's the derivative of negative x over 2? Close? Yeah. I call it negative 1/2. Because like the x disappears, right? You know what I mean for that. Okay, now I know what you're thinking. You're saying to yourself, wow, this is evil. We're back to solving trig equations. Okay, and we are. Remember we said how many solutions are we going to get here between 0 and 360? 2. No, whoever said at least 4 is wrong. Okay, because what would happen is, Victoria, if this said sine 2x, then there'd be more sets of solutions, right? But because it's just sine x, there's going to be 2 solutions, okay? Chris, go ahead.
Okay, so you set it to 0,
Good.
the f prime x, and then can I just solve it straight away? Okay, so then it just becomes, you bring over the 1/2 over, and then you do cos inverse, and it becomes x equals 1.047. I don't remember my unit circle thing.
My heart just skipped a beat there. Oh my goodness. Now, Chris, I will take a mark off if I give you a nice number like 1/2, and you tell me it's equal to this. And when you get to the University of Toronto, which you're showing out in your beautiful jacket and your coat and your bag today, they will also probably not let you use a calculator in first year. Okay, so you will have to know these things on how to do them. All right.
I still remember
Chris,
like, doing unit circle.
Shame on you, because I taught it to you in grade 11.
Did you?
Maybe I did. Maybe that's right when I sort of fell off.
I don't remember.
Makes no sense to me. I don't.
Now, what's the other angle for cos? Hold on. What makes the other angle for cos?
Plus pi.
No. No.
For which one? For this one?
Oh my goodness. I'm glad we did this today. Yes. Now hold on a sec. Before you guys saying, I don't understand unit circle. You learned this in grade 11 and 12. Okay, so in grade 11 you did this as well too, and you should have. But now, no, we're not memorizing it. Hold on a sec. We're not memorizing it. You have to know though from start. As soon as you see a nice number like root 3 over 2, or 1/2, or 1 over root 2, just wait. No, well, pi over 3 plus pi is 4 pi over 3. Right?
Why are you so far?
Don't you also have to add it as well?
Now here's the thing. If I add the period, what's the answer going to be?
Above 2 pi.
Above 2
Oh,
pi,
okay.
so we don't have to.
Well then, oh, yeah.
Now just a reminder, I'll put a reminder here, because these are 3 identities which you may need. Now you don't have to write this down, but this is faster than cast. If you have sine x equals k, where the solutions are x and pi minus x. For cos of x equals k, my solutions are x and 2 pi minus x. And if you have tan x equals k, my solutions are x and pi plus k, or pi plus x. Okay? So those are good, quick ways, and this is the way I teach it in grade 11, because that's a 180 minus, 360 minus, and 180 plus, if you're in my class in grade 11. Okay. Does this come back to anybody? Anyone in my grade 11 class? I know. I think Nicole was.
Yeah, I don't remember.
Maybe I wasn't hearing this. I know you were. No. You want grade 11? Okay. But I know. I think when you were in my class, I sort of flopped out somewhere around this part in time. I think.
You left during
Yeah.
the like vectors and.
You left before the midterm because.
Yeah. So anyway, but the point is here, this is something to remember, which will help you out. This you can use, and you can get the same information from cast. Okay, for sine, you have one angle here, the next angle is here. It's 180 minus. From cos, you have one angle there, the next angle is there, so 360 minus. From tan, you have one angle there, and the second angle there, 180 plus. plus. The same rules as tan, the same rules as cast applies. So
Can you explain that? Where is it?
what I just wrote here, hey, hold on, please. Okay, so what I just did here was, I just basically proved cast in a quicker way. So if you have your first angles in the first quadrant, where's your second angle going to be? If you're something in all, where's the next angle going to be? Well, in S, right? Okay. So all I'm saying then is this little angle here matches that little angle there. That's what I'm saying. So that's the same as theta and 180 minus theta, or pi minus theta. Okay, because this little part here matches this little part here. One more time. Oh, that just means the solution. That's what it means. I couldn't really write it out as neatly as I wanted to. Okay, and the same thing for cosine. My first angle's here. My second angle's there. Okay, so we're going to have my, how does this one go? It's this and this. These two have to be the same, so my first angle is this, the second angle is this. Alright, and tan, because it's a straight line, you have this and then you have this. So 180 plus. That's the quick version. Colin, you never raised your hand. You were in my grade 11 class. Does this remind you, do you remember this at all or not?
I remember it a little bit, but
It was 180 minus.
yeah.
We use 180 is what we use instead of pi. It was obviously. Okay, Michael, that's your first to know. Oh, that's just a fast way to do cast. Okay, so if you don't like cast for finding solutions, that's the faster way to do it. Okay, so if you want to use cast, just ignore what I was on the board. Okay, and use cast. If you want to use the fast way, you may use the fast way. What? No? The same question.
What is it?
K is just a solution. It's just going to be like sine theta is 0.5, sine theta is 0.2, or sine of x is equal to just something, right? But when you get the solutions, it's going to be, there's going to be two solutions, right? And that's where you get the two solutions from. No, go ahead.
Can you make the whole exam of that one?
Can I? Yes. So I don't think there's any degrees because there's no vectors, right? I don't think I did anything crazy like that assignment where one person's going here and one person's going here. Right? There's nothing like that that needed degrees. I think that's the only other question we did. Yes.
This might be a stupid question.
No, it wouldn't be a stupid question.
But is there a reason why there's no comma after the K for cosine 10? Was that a stupid question? Because I'm confused. I don't. Is it K approaching X?
No.
The answer is.
Sorry, I was trying to be as. The answer, if you assign theta equals K, that means my solution is X and pi minus X. Okay. For cos X equals K, my solution is X and 2 pi minus X. And then for tan X equals K, the solution is X and pi plus X. Okay, have I confused everyone yet? Okay, one person's nodding, shaking his head. That's good, Derek. Okay. Let's go for my points of inflection now. Yeah, it's going to be the second derivative. So we had f of x, f prime of x is equal to, what was it, cos x minus 1/2. Okay, I'm going to pick on someone at random, that being my good friend James Campbell. What's the derivative of cos, please? Good, what's the derivative of negative 1/2? 0. So we need to solve the equation then, 0 equals sine x. Okay, now this you can get from a unit circle. Okay, we can do this right away. So I'm going to draw this on the board. Sine is going to be your x values and your y values. Where does sine start as a graph?
At the beginning.
Well, it's negative, but then I switch over to positive because you multiply them both by negative and it doesn't change.
Hey, use a different burger.
No. Do it on here.
It starts at the origin, no?
It starts at the origin.
We're gonna be 0.
So this is going to be at 0. There's going to be a solution. When else does this graph hit 0? Pi.
And 2 pi.
Thank you. So my solutions are sine, and you get this on your calculator too. So sine x, so x is equal to pi. Oops, 0, pi, and 2 pi. Now hold on, just for how we got this again, right? Remember the graph of sine starts at 0, so that's 0 here. What else is going to hit 0? Over here at pi, and over there again at 2 pi. Let's go.
You like side there.
Yeah, and you can do that if you want to. So, okay, hold on. So the way, if you want to use, I like what Bailey's saying here. She likes to use the rules, which is good. So let's say you just do this in your calculator, and you're going to get x equals 0, right? Then you're going to say, well, x is also equal to pi minus 0, which equals pi.
And then 2 pi minus 0, which is...
No, hold on, leave the 2 pi minus 0. Then what you're going to do is you're going to add your period, which is 2 pi, and you get x equals 2 pi. All right, how are we doing for time? We're good. Okay, if this question is causing you stress, okay, this is one to do before your test, hint, hint. Okay, if this question is causing you stress. Now, all we're doing, before you say, Mr. Shaw, this is awful, all you're doing is a very simple derivative. Like, you got to admit, this isn't hard going from here to here, right? This is easy. This is the easy part of the question. Then it's just advanced functions from before. If I didn't explain it as well as your advanced functions teacher, I'm sorry, okay, but I'm trying just to, that's the best way I can do to explain the cast, right? No songs, you're a pro at unit circle, right? Okay, right, so this made sense, some of what happened to me? Okay, good. So it's 2 nods ahead. All right, what do we still need? We still need domain and intercepts and things like this. Domain, intercepts, and asymptotes.
And caffeine.
What's the domain for any sine function? Do we have any intercepts? Do we have any asymptotes? Excuse me.
Probably somewhere.
No. And we're going to have... Okay, stop. And we're going to intercept equals f of 0, which equals 0. General point is 0, 0. So, how would you know if there'd be an asymptote? Okay, Luke, stay in the zone, please. How would you know if there's an asymptote? Rational. That's the only type of equation they're going to have it. If I get you to graph sine of x over x, there'd be an asymptote, right? If I were to do something like that, okay? But if it's just going to be something plus something else, unless there's a fraction in it, there can't be an asymptote. Does that make sense? Okay. We still need to get a few more things before I graph this. I need f of 0, f of, what was my first one? Okay, can I get 5 volunteers? First volunteer is going to be Alistair. Can you find f, actually I already did that one. Can you find f of pi over 3 for me, please? The next volunteer is going to be Cecilia. Can you find f of pi for me, please? The third volunteer is going to be Noah Solinger. Can you find f of pi for me, please? Did I already f of pi? F of pi over 3. And the last one is going to be Austin DeVries. Can you find f of 2 pi for me, please? Yeah. No, this is the original function. So you're going to sub this into f of x equals, what was it, sine x plus x over 2. Is that right? Or minus x over 2, sorry.
Wait, why did we assume there's no asymptotes again?
Because there's no fractions in the question. But if that was like x to 1 over x or something like that, then there'd be asymptotes, right? I bet there's a number in there, but that's okay. I bet there's an exact value there, but I'm not going to yell at you right now. Okay? No, Sandra, did you get yours? Cecilia, did you get yours by any chance? I think there's also a special, an exact number there, but I'm not gonna yell today. 32 pi, awesome, touchers. And no Sonder, -3.48. Okay, looking at my chart, how can I tell this is right? What is f of pi over 3 and 5 pi over 3 going to be?
If they're going to be negative because
Okay, no, even more than that. What is f prime? Those are my critical points. What are critical points again?
first derivative.
Good. Go ahead. Good. What else? Yes. What else?
Is it where it changes? Right.
Yeah, sort of. Right. So your highest point on there is going to be 0.34. The graph's going to, I guess, go up a little bit, then go way down to -3.48, then come back up a little bit to -5. Okay. And both of those were when f prime of x is equal to 0. Yes. Well, I just looked at them because you can. There is a check to do it from max and min, but I'm not going to make you guys do it. You can find f double prime is positive, which would mean that it's going to be max, and f double prime is negative, would make it min. But I'm just going to go with this, that 0.34 is the biggest number there, and -3.48 is the smallest number there. So that's for the chose there. Yeah. Yeah, you can do it the same way. Yeah.
So
Possible. Yes.
you wouldn't take off marks if we wrote f pi like you did there instead of f pi over 2.
One more time.
F of pi.
Oh, this is pi over 2, right? Yeah,
Yeah.
that's fine. Okay, so let's get my interval chart here. So I'm going to say, oh sure, I forgot my interval chart. Interval. So I'm going to say x is 0 is less than x. Okay, why can I stop there? That's my domain. Excuse me, I have no points at 0 and 2 pi, but that's my domain for the graph. Okay? Awesome as well? Okay. I'm glad you're here today. That really warms my heart. What you snicker? It's ice. Awesome. All right. So then what we're going to do is we're going to say f prime of x, f double prime of x, and shape. Okay, pi over, can somebody sub pi over 6 in? Oh, I'm going to pick volunteers again. Emma, I'm picking on you. Can you do the first one, please? Please. That was a please. Callan, can you do the second one, please? Chris Wee, can you do the third one, please? You always like to volunteer.
I know, but I'm
Victoria.
really not confident in these ones.
You just sub the numbers into your calculator. This is just calculator work.
I still
And
don't
Victoria, can you do the last one for me, please? So you pick a number for this one, like maybe, I don't know, 5.5 pi over 3, you know what I mean, or something like that should be the right answer. Yeah. Now the other thing to do in this case, it's okay to switch it to a decimal. If you go realize that pi over 3 is 1.04 like Chris did, you can pick an answer for 0.5 and sub 0.5 into your equation. Right? Now, I would recommend strongly right now to pick one yourself to do and make sure you get the same answer as these people that are going to give you the solutions. Okay, because you will be responsible for this. So you will not be able to sit beside Matt, who's the best grapher in class, and say, hey Matt, what'd you get for this question? Okay, I'm just so not to scare you all, but I turned, and you guys have never been in my class before, I turned it sideways. So I sit up the front like this, like I'm Mr. Honish lording over you. I just wish I had one of those things that, what are they called, pedestals? You sit down. Math is wonderful. Anyway, and you guys are all lined up like this down this way, so you're far enough away from everybody you should be able to see. All right, so even if you want to, which you guys don't, but the point is you won't get asked that for help. So take a second, pick one, figure it out. What? Go, go, Matt. Go, go. All right. Who's my first person? I can't remember now. How was that you? What'd you get? What does a positive and negative look like, please? Sort of like that? Or like that? Yeah? All right. Which one do you have? Second one?
Second, I got positive for both. I don't know.
Yeah, that looks good to me. Positive for both. Are we sure about that? We'll leave that for right now, but if we did, it would go like this. The only reason that I'm curious about that count is because we had 0.34 at local max. You know what I mean? So it should probably be dropping there. We'll leave it on the board for right now.
Negative sign, that's well.
Oh, okay. So that'll just both be negative.
Yeah.
You're not to like X less than 0.
No, because in this case our domain is just 0 to 2 pi, so we don't need to. Right? But for a regular graph, you would need to do that. Okay, who's the third person? Chris, you got it? No, you're the third person? Yeah. Go ahead.
It's negative and positive.
Yeah.
And so that becomes like from the top and then to the right.
Good. Okay, and last but not least is Victoria.
Positive, positive.
Positive, positive. Something like this. I'm not going to graph it if that's okay. I'm sorry if you're offended by that. If you've already used your graph, sticky on your page, then you can continue to use it. Okay.
They're valuable.
Those are. I'm sorry.
Should have told.
I'm sorry. Just I want to keep going for time wise. I want to get through some more stuff. Yeah, Mike, go ahead. Okay, I'm going to hit pause in the video, and then we're going to go through another related rates question for the assignment. Who is the first? Oh, sorry. Go ahead. Good question. Okay, now the way this graph's actually going to look. Okay, guys, what is check off for second, please? It's a really good question, right? Really good question. The question is why do we not need to write the horizontal asymptotes? Because if you just give me a second, please. Okay. What does the graph of negative x over 2 look like? It's going to go downward. So negative x over 2 is going to look something like this, right? If you add sign to that, it's going to go like this. So there's not really a horizontal asymptote to it. It's more of like a double oblique is what you'd say, right? Yes, but I'm going to leave that for the sign code, so you don't need to worry about asymptotes, just because this is really what the graph's going to look like. So, and if you guys remember, you guys did composite functions last semester at the end. Remember you're adding different functions. That's all we're doing here, right? You're starting with x over 2 or negative x over 2, then you're adding sign to it. Which is awesome. Okay, that's an awesome thing. Again, I'm a math teacher, so these things are useful. Luke, it looks like you just went, one-on-one with Steph Curry. You're looking so tired. Are you okay?
Yeah, I mean,
Okay. So I should put Steph Curry. This would be awesome. Russell Westbrook.
Okay.